Alright, so this example is a little different than the last one. This one has a natural log function. It's got a 4x times the natural log of x. Again, I can't solve it with the substitution. There's no u to substitute out. It's just one function times another function. There's no composition. Now, the e function, we always made the antiderivative case, and the x term, we made the u case. This is going to be the exact opposite, because if you try to do the natural log here in the dv part, remember, I've got to take the antiderivative of that. We don't have an antiderivative for the natural log, so you can't put the natural log here. This problem forces the natural log to be the u term. But remember, the derivative of the natural log is 1 over x. 1 over x is simpler than the natural log. I actually get, excuse me, I get rid of the natural log expression. Alright, which leaves the 4x and the dx to go in for the dv spot. So 4x dx, which 4x is not a bad function to take an antiderivative of. It's just a simple power rule. Alright, I'll get my derivative. 1 over x. So this one's going to be a little bit more complex because it's not a direct du dx. It's a 1 over x dx is my du. Natural log is my u. Excuse me. And then my antiderivative. Which, remember, the antiderivative of this is 4x to the second divided by 2, which that simplifies really nicely. The 2x squared. Alright, and so it was an easy antiderivative to find. So there's my three pieces. U is equal to the natural log. V is equal to 2x squared. And this is the one that's a little more complex. I've got 1 over x times dx. But remember, 1 over x is still simpler than the natural log function. Alright, so we plug in all the pieces to this part. So we get u, which was the natural log, times v, which was 2x squared, minus v, which was 2x squared. And then this is the part you've got to remember. If I'm going to forget something, this is the part I'm going to forget. Du is equal to 1 over x dx. I've got to remember that. 1 over x dx, not 1 over 2. 1 over x dx is what we'll replace here with du. Alright, so I'm actually going to simplify that before I go and take my antiderivative. I'm going to move this to the front just because it's more proper to write it that way. Again, that's a minor thing. And then here, I can reduce. Right? 2 times, instead of x squared divided by x, it's just 2x dx. Which that's a simple antiderivative find. So again, I'm going to do my integration here. So 2x squared natural log of x minus the antiderivative of 2x, so it's 2x is second divided by 2, and then that's where my constant comes into play. And so my family of antiderivatives is 2x squared times the natural log of x minus x squared plus c, and there's my answer, which again, I can always check. This is the last one that I'm going to go through the process of checking with you, just to show you that even in this case it does check. Alright, when I take the derivative of that, I do have to use the product rule here. So 2x squared times the derivative of natural log, which is 1 over x, plus the natural log of x times the derivative of 2x squared, which is my 4x, minus x squared, which is 2x. The c constant cancels out. Simplify here, and that simplifies to 2x. 4x natural log of x minus 2x. Well, the 2x's cancel. And there's my original expression, and it checks. Alright, so again, even though these are complex, and the complex part is just plugging it in the formula correctly. Again, I would just encourage you to have that formula ready to go when you're practicing these. Alright, we'll stop there. We'll pick up the next one in the next video.